All right, today we're going to tackle a big one, trigonometry. But forget everything you think you know about it. We're not doing dense textbooks. We're going to break it all down to its simple core ideas and see how they all snap together like perfect puzzle pieces.
Let's be honest, that word, trigonometry, it just sounds complicated, doesn't it? It's got some weight to it. But I promise you, behind that intimidating name is a set of ideas that are surprisingly simple and incredibly powerful. We're just going to build it up from scratch, one easy step at a time.
And here's the secret. Don't think of it as some giant mountain you have to climb. Think of it more like a bunch of simple, interlocking building blocks. Once you understand the blocks, the whole structure just snaps into place. So let's grab that very first piece of our puzzle.
Okay, our first big concept is the trigonometric function. Now, don't let the word function throw you. In math, a function is really just a rule. You know, a rule that takes an input and gives you a predictable output. So the real question is, what's the rule here?
Aha! So a trigonometric function is just a function whose rule is something called a trigonometric ratio. That kind of feels like we're just chasing our own tail, right? To get the function, we need to understand the rule, the ratio. And to get that, we first have to know where all this stuff even happens. So let's just lock this in. We have a function, which is just a rule, and that special rule is called a trigonometric ratio. But before we can really dig into what that ratio is, we have to set the stage. We need to introduce the absolute star of the show.
And that stage, well, it turns out to be one of the most famous, most fundamental shapes in all of geometry. All of these ideas, the functions, the ratios we're talking about, they all come to life inside this one single perfect shape.
Yep, the right triangle. That perfect 90-degree corner is the key to everything. This is our playground. It's our entire universe for this stuff. Everything happens right here. So now that we know our setting, let's get back to that mysterious rule. And now we're getting to the absolute heart of it, the trigonometric ratio. This is the engine. This is the rule that makes our trigonometric function work. So, what is it really? And you know what? The definition is actually beautiful. A ratio is just a fancy word for a comparison. And in this case, all we're doing is comparing the lengths of two sides of our right triangle. That's it. It's not magic, it's just a simple comparison.
We're literally just taking the length of one side and comparing it to the length of another. Simple, right? But that immediately makes you wonder, wait a minute. A triangle has three sides. How do we know which two sides we're supposed to compare? Well, for that, we need a point of view. And this is where our final piece of the puzzle comes in. It's a special symbol, a Greek letter, that you are going to see all over the place in trigonometry. Think of it as our guide, our anchor point inside the triangle. And there it is. This is theta. It might look a little strange, but its job is simple and it is absolutely essential. It tells us which corner of the triangle we're looking from. So theta just represents an angle. Specifically, it's one of the two sharp corners in our right triangle, not the 90-degree one. By choosing an angle to be our theta, we've set our perspective. And it's that perspective that finally tells us exactly which two sides we need to compare. Okay, let's do a super quick recap of how all these blocks fit together. We have a trigonometric function, which is really just a rule. That rule is a trigonometric ratio. A ratio is just a comparison of two sides of a right triangle. And how do we know which two sides? It all depends on our point of view, that little angle we call theta. See? It's a perfect logical chain. And that leaves us right at the edge of the next big step. Now that we have our ratio and our point of view, theta, which two sides do we actually pick? The answer to that question, well, that's what unlocks the true power of trigonometry. Thanks for diving into this with me.